So here we have another limit that shows up from time to time in the derivations of these trigonometric derivatives. It is the limit as theta goes to 0 of the cosine of theta minus 1 all over theta. You'll notice that if we attempt to use the direct substitution property with this, we'll get the cosine of 0, which is 1, minus 1 all over 0, which is 0 over 0, one of our indeterminate forms. As such, this means that we are going to need to perform some sort of manipulation with this. The manipulation that I am going to perform with this is to multiply top and bottom of this fraction by the conjugate of the numerator. So we'll be multiplying top and bottom by the cosine of theta plus 1. Now, up top, as I frequently say at parties, product of binomial conjugates will turn into a difference of two squares. That is the cosine squared of theta minus 1 all over theta times the cosine of theta plus 1. And we're just going to go ahead and leave that as is. Now I will ask you to recall with me an important identity from back in trigonometry, that the sine squared of theta plus the cosine squared of theta is equal to 1. Now, the idea is I'd like to turn this identity into what I see in the numerator, so I'm going to subtract 1 from both sides, and I'm also going to subtract the sine squared from both sides. So when I see cosine squared of theta minus 1, I can replace that with the negative sine squared of theta. Good old Pythagorean identities. They do tend to show up quite frequently when you see squares of trig functions. Now at this point, I am going to separate this into two different expressions, or rather the product of two different expressions. One of those expressions, I'm going to borrow one of the factors of sine of theta from the numerator and put that over the theta that's in the denominator. Then I'll take the remaining negative sine of theta and put it together with the cosine of theta plus 1 that's in the denominator. The reason that I do that is because the limit as theta approaches 0 of the sine of theta over theta is the limit that we derived in the previous video. That is going to go to 1. Times, and if I use the direct substitution property for the other part, that'll be the negative sine of 0 over the cosine of 0 plus 1, better known as 1 times 0 over 2. Good news is there is a 0 in there, so that is going to wind up being equal to 0. So we are going to see this limit show up a couple of times as we are coming up with derivatives of the sine and cosine.